All right. Section 2, arcs and chords. And we're going to start off with a central angle. Is an angle whose vertex is the center of a circle. And an arc is an unbroken part of the circle. Consisting of 2 points called endpoints. And all points on the circle between. So a central angle would look something like, you got a circle, right? That circle's got a center. A central angle is an angle whose vertex is the center of the circle. So that would be a central angle, wouldn't it? This would be an arc. An arc is an unbroken part of the circle consisting of endpoints and all points on the circle between. So say you got a point A and a point B. Those are your endpoints. The endpoints and all the points in between are called an arc. That arc is formed by this central angle. Yes, sir?
So that means any other angle is probably considered a central angle. Right?
Any angle whose vertex is on the center of a circle.
Okay.
So you could have another central angle in this same circle. All right? And maybe this center is O. So angle COD would be a central angle. Angle AOB is a central angle. Good?
Yeah.
A minor arc is an arc whose points are on or in the interior of a central angle. The measure of the arc is equal to the measure of the central angle. So you got a circle. Circle's got a center. Then you've got an angle. Angle whose vertex is on the center of the circle. That makes this a central angle. Whatever this degree measure is of this central angle, let's say it's 85 degrees. Then this arc measure, I'm going to use AB again. Then arc AB is equal to 85 degrees. All right, we just said that AB is a minor arc, right? That makes around the back. See the arc around the back of this thing? I'm going to put a point here. Call it C. If AB is a minor arc, then arc ACB is a major arc. A minor arc is an arc whose points are on the interior of the central angle. Major arc, exterior of the central angle.
So will major arcs always consist of 3 points or more?
Major arcs are always described with 3 points. Because if you described the major arc, AB, it gets a little confusing. So when you're describing arcs, you go from one point directly to the second point in the description. Okay? When you're talking about arc AB, that means you start at A, you go directly to B, shortest path possible. When you're describing this major arc, ACB, it means you're going to start at A, you're going to end at B. But since C is in between A and B, you have to go this direction. You have to go through point C on your way to point B. Okay? Minor arcs, 2 letters. Major arcs, 3 letters. So, can you see another rule here then maybe about the measure of a major arc? Go ahead. The major one's going to be greater than the minor one. But what do all these angles inside of this circle add up to? Yeah, 360 degrees. So won't this major arc be equal to 360 minus its minor arc? Yeah. So in this case, the measure of arc ACB is equal to 360 minus the measure of arc AB. So the measure of arc ACB equals, what's 360 minus 85? 275? And if the endpoints of an arc lie on the diameter, the arc is a semicircle. Everybody good? Going to look at example 1, the data application on the bottom of page 802. There's a circle graph, shows types of music sold during 1 week at a music store. So you've got this circle graph. Find the measure of arc BC. The measure of arc BC. B to C. What's that deal with? Do you see it? Did you find it yet? Deals with wrap and what else? Goes from, oh, it's all wrap, isn't it? Goes from B to C. It says this piece of the pie is 13%. So the measure of arc BC is not 13, is it? No. Because percents are out of 100, right? And now we're dealing with degrees of a circle. And how many degrees are in a circle? 360. So don't we need 13% of 360? Okay. So the measure of arc BC is going to be equal to 0.13 times 360, right? 13% of 360. What's 13% of 360? 46.8? Thank you. 46.8. Now look, that's degrees. That's the answer. That's the measure of arc BC. This arc BC right here is given in degrees. Can't find the length of it until you know the circumference or radius of the circle. Right now we're just going to deal with it in degrees. All right? Look, so what's the measure of this angle right here? 46.8 degrees. Very good. Yeah, so if you needed arc B, I'm not going to add any letters to this yet, but the major arc around the backside would either be 360 minus 46.8 or 87% of 360, right? Because if this portion's 13% of 360, then the rest of it's 87% of 360. So the second question they ask you there is the measure of angle FMC. Same concept, okay? FMC, F to M to C. So this goes like here. And this is F, the center is M, And there's a bunch of percentages you have to add together, right? Like 3, 9, 10, and 11. Everybody see that? Remember angle addition postulate? If you need this entire angle right here, isn't it the sum of all of its angles? So what is 3? No, it's just 9, 10 plus 11, right? Because F to E is 9, E to D is 10, and D to C is 11. So what's that, 20? 30, like I said. So all of this is 30%. So you need 30% of 360. So what's that, 0.3 times 360? 108 degrees. Measure of arc. Bless you. AHB. A is up here at the top. It's almost the whole thing is right. It's almost the whole thing except for how much?
25. It says that.
Except for the red part, right? So A, now they put the H in there because they want you to go through H on your way. H is over here somewhere. So it's this larger portion, isn't it? And this piece is 25%. So AHB, wouldn't that be 75% of 360? 270? All right, so 270 degrees.
Wait, how did you get that?
This piece right here, was 25%. That means the rest has to be 75%. From A through H and ending up at B. The rest of the circle. So 75% of 360. So 0.75 times 360. Top of 803. Adjacent arcs. Adjacent arcs are next to each other. And intersect at one point. If you got a circle, and let's say point A and then point B on the circle and point C. Don't you have an arc right here, AB? And isn't that next to an arc, BC? What point do they share? B. So they're adjacent arcs. They're next to each other. They share a point. So doesn't arc AB plus arc BC equal arc AC? Good. That's just like segment addition postulate, angle addition postulate. We'll call it arc addition. Oh look, the book calls it arc addition postulate. What a unique name. Right? What about arc AC minus arc BC?
Equals AB.
Arc AB, very good. All right, so let's do example 2. Let's see, A to D looks like a diameter. All right, here we go. We got points A, B, C, D, E, and F. So A, B, C, D, E, and F is the center of this circle. This is a 90-degree angle. BFA is 18 degrees. 18 degrees. And they want arc measures. Measure of arc. CDE. So you're going to identify the arc first, right? Arc CDE goes from C through D and it ends at E. It'd be 90 plus 18, exactly. This 18 is a vertical angle with DFB, right? So isn't this angle also 18 degrees? You know what's easier to do sometimes is just fill in all the angle measures first. All right? You know that this one's 90. It's got the symbol there. These two are vertical angles, so they're both 18. What's angle BFC going to be equal to?
72.
It's 72, right? The 90 minus 18. So this is 72 degrees. Now, look at this angle down here on the bottom, AFE. What is the measure of that whole diameter angle? 180, right? Half the circle. So what's 180 minus 18? What is it? 162. So this angle is 162 degrees. So now you've got all, does everybody see how all these angles, how we got all these angle measures?
Yeah.
They've all got to add up to 360. A, from point A to D, it went from one side of the circle to the other through the center, so that makes it a diameter. So it had to be 180, and if you subtract the 18, there's 162 of it left. So CDE, that's going to be 90 plus 18, which was, what is that, 108?
Yeah.
108. What else do they want to know? That's all that work for that? Yay. All right, let's do the measure of arc EAB. EAB, what's that going to be equal to? 180, good. See, once you fill in all the angle measures, it's not even any fun anymore. It's just too easy. Any questions? I can't tell if that next congruent arcs. Let's just get that definition in your notes, and then I'm going to give you some practice. We're not going to go any further than that today. Within a circle, or let's just say congruent arcs, have the same measure. Congruent arcs have the same measure, so if you were given a picture like this, remember the tick marks? If this arc has a tick mark on it and this arc has a tick mark on it, I don't know, they're probably called arc marks now. then doesn't it mean that arc AB is congruent to arc CD? All right, and if this angle was, you're probably going to get something, I don't know, if this angle is 2x plus 10, and this angle is 4x minus 6, could you solve for x and find the angle measures?
Yes.
Yeah, you would set the angles equal to each other, right? Because if the arcs are congruent, then the central angles are congruent, and vice versa. If the central angles are congruent, then the arcs are congruent. All right, I'm not going to finish that. I'll finish it. Do 2x plus 10 equals, I just made it up, so we'll be able to find some kind of number here. Subtract 2x from each side. So 10 equals 2x minus 6. $16 equals 2x. Huh? So divide both sides by 2. 8 is equal to x. There's your value of x. So this angle measure would be 2 times 8, which is plus 10. 26 degrees. Any questions?
No.
All right, your assignment or practice for today is on page 806. Five through 14. And then over on the next page, 25 through 28. No, make that 19 through 28 on the next page. And when you check Headline for homework, make sure you've got yesterday's assignment and today's assignment open and in front of you.